G'day, welcome to another video from McMaths. Our topic today is using logs to solve for n in the compound interest formula. So we're going to look at specifically using the logs for this particular scenario. Often we're required to do that prior to learning all the ins and outs about logs, so you just use this particular skill in this scenario. So looking at our question, we have $2,000 is invested at 5% per annum, compounding annually. How long should it be invested to double the amount? So the how long part tells us we're solving for n. We're told that our $2,000 is invested, so that's our principal. We know that it is at 5% per annum, so our interest rate is going to be 0.05 when we write it as a decimal. Our n we don't know. Now our amount, this is where sometimes students say, well, I don't know, they haven't given me the amount. So this is the key part here, is it's doubled the amount. So if our $2,000 has doubled, we now have $4,000. Sometimes they'll word it in ways of to earn a certain amount of interest. Now if we wanted to earn $500 interest, then we would make our amount $2,500 because we've got our original $2,000 plus the $500 interest. So that is another way that you might see this question presented. So looking at this one, we'll now sub into our equation what we know. So we have $4,000 is equal to 2,000 outside of 1 plus 0.05 to the power of n, because we don't know what that value is. Now our first step is going to be to do the 4,000 divided by 2,000. So we get 2 is equal to 1.05 to the power of n. So I've just simplified what's in that bracket to 1.05 and I've got my power of n there. Now an option is to just do trial and error by doing different values of n to see when you get close to 2. Obviously that can be quite time consuming, so we're going to use logs to do it. So when we use our logs, we just write log 2 is equal to log 1.05 to the power of n. Now when I write log 2 and I don't write any base there, I'm assuming it's base 10. So now that we've got it in this form, one of our log laws allows us to take that power and bring it out the front. So we can write n log 1.05. When we get further into the methods course in Unit 3, etc., we will go into our log laws in more detail. But at the moment, this is all that we're using it for. So we can bring that n down the front. Once we've got it at the front, that's when we can now divide and get the n on its own. Log 2 over log 1.05. So we grab our calculator. We're going to write log 2, put my bracket, divided by log 1.05, end bracket, press enter, and we get 14.2. Now that means, like, if we're talking about investing it for different numbers of years, we're going to have to round that. So after 14 years, it won't have doubled yet, but after 15 years, it will have then doubled the amount. So we will have to write 15 years and round it up to the next number of years, because if we rounded down to 14, we wouldn't have gotten to double the amount yet. So if we put in that 1.05 to the power of 14, see how we're only at 1.97? We haven't gotten to that 2 yet that we were after. When we put in the 1.05 to the power of 15, you'll see we've now got to 2.07, which is now over 2. We could then also, if we wanted to check, go and pop it back in here and do 2,000 times 1.05 to the power of 15. And we'll see we get 4157, and we were wanting to get 4,000. If we put in the 2,000 times 1.05 to the power of 14, we would see that we only get 3,959, so we haven't doubled our money yet. So that's why we go to the next year.